Have you ever been stuck in traffic under a massive flyover and wondered how engineers managed to build something that seems to float above the ground, carrying thousands of vehicles every single day? Those towering concrete structures don't just appear magically overnight. Each one is a product of incredible planning, precise calculation, and some of the most advanced construction engineering techniques on Earth. Today, we'll uncover the hidden process of how these giant flyovers are designed, engineered, and built to stand strong for decades, sometimes even centuries. Imagine looking at a city from above, crisscrossing roads, looping bridges, and highways that glide smoothly over each other. That's not chaos, that's engineering harmony. And it all begins long before the first concrete is poured. So let's dive deep into the fascinating world of flyover construction. Why flyovers are built. Before a single piece of steel or concrete is used, there's one important question. Why do we need flyovers in the first place? As cities grow and populations explode, traffic becomes a major challenge. Roads become congested, intersections choke with vehicles, and travel times increase dramatically. Expanding roads horizontally doesn't always help because urban land is limited and extremely expensive. The only direction left to build is upward. That's where flyovers come in. Instead of expanding outwards, engineers elevate one road over another. This allows traffic to move freely in multiple directions without interruptions. Think of it like adding a second floor to the city's road system. Flyovers save time, reduce congestion, cut fuel consumption, and improve safety. They're not just structures, they're lifelines for modern cities. Planning and design. Every flyover begins as a vision, an idea drawn on a map by city planners and engineers. But transforming that idea into reality requires months, sometimes years of planning. Engineers begin by studying the area, the traffic volume, the soil type, the space available, and the surrounding infrastructure like buildings, pipelines, and electric lines. Using computer simulations, they find the most efficient alignment, the exact path the flyover will take, balancing safety, space, and cost. Once the alignment is fixed, designers choose what kind of flyover to build. Some are simple beam structures used for shorter spans. Others use box girders for extra strength. And in some cities, you'll see segmental or cable-stayed flyovers that look futuristic and elegant. Every detail, from how sharp a curve can be to how steep the slope should feel for drivers, is calculated with precision. Then, with the design ready, engineers prepare for the most crucial step: what lies beneath the surface. The foundation. Just like a tree's roots, a flyover's foundation decides how strong it will stand. It's the invisible hero buried deep below the ground, carrying the entire load of the structure above. Engineers start by examining the soil with special tests to measure how much weight it can support. If the soil is weak or unstable, they use a deep foundation method known as piling. Long cylindrical shafts made of concrete or steel driven deep into the earth. These piles act like legs, transferring the load to stronger soil layers below. In areas where the ground is already firm, open foundations are used, large spread-out concrete blocks that distribute the weight evenly. Massive drilling rigs, cranes, and pile drivers fill the site as the foundations take shape. Once they're ready, the stage is set to rise above the ground, and that's where the magic starts becoming visible. Building the piers and columns. The tall columns you see holding up a flyover are called piers, and they're the next major step in construction. Each pier must be placed with absolute precision, because even a few centimeters of error can affect the alignment of the entire structure. Engineers begin by creating steel reinforcement cages, which act like the skeleton of the pier. Then they set up large formwork molds, giant hollow shapes that will give the pier its form. Concrete is poured into these molds, surrounding the steel cage and left to cure until it reaches full strength. Depending on the design, some piers are tall and slender, while others are thick and heavy to handle extra loads. The spacing between piers is carefully planned. Too close wastes materials. Too far makes the deck unstable. Once these vertical giants are ready, the flyover starts to look like a real structure rising from the ground. Pier caps and bearings. At the top of each pier sits a thick concrete block known as a pier cap. Think of it as a shoulder that carries the weight of the deck above and spreads it evenly across the pier below. But before the deck can be placed, there's another critical component: the bearings. These small but vital parts sit between the pier cap and the deck, allowing the structure to move slightly as temperatures rise and fall or as vehicles pass by. Concrete may seem solid, but it expands and contracts with heat. Without bearings, the flyover would crack or deform over time. There are different types of bearings: elastomeric, pot, and spherical, each designed to handle different loads and movements. Once the bearings are installed, it's time to build the most visible part of the flyover, the road itself. The deck, or superstructure. The deck is what you actually drive on. It's the horizontal slab that connects one pier to another. There are two main ways to build it. The traditional method is called cast in situ, where workers build the formwork directly on site, place steel reinforcements, and pour concrete into it. This method is strong and reliable, but takes more time because the concrete must cure on site. The more modern technique is called precast segmental construction. Here, huge segments of the deck are manufactured off-site in a controlled factory environment. Once they're ready, they're lifted into position using giant cranes or special machines called launching girders. These massive yellow structures move across the piers, placing each segment in its exact position. The segments are then joined together using post-tension steel cables that run through them, tightly compressing the entire deck into one strong unit. This method is faster, safer, and produces better quality since everything is made under controlled conditions. Watching one of these machines lift segment after segment is like seeing a giant puzzle come together in midair. Expansion joints and drainage. Now that the deck is complete, it's time to make it durable. Engineers install expansion joints at intervals along the deck to allow it to expand or contract with changes in temperature. Without these joints, cracks would appear, and the deck would quickly deteriorate. Along with that, drainage systems are added to carry away rainwater. If water collects on the surface, it can seep through tiny cracks, rusting the steel and weakening the concrete over time. Small details like these often go unnoticed, but they would make a flyover last for decades instead of just a few years. Ramps and approach roads. A flyover can't exist in isolation. It needs ramps and approach roads to connect it to the existing network below. Engineers design smooth transitions that allow vehicles to enter and exit safely without sudden changes in slope. These ramps are built with gradual inclines so that even heavy trucks can climb easily. During this phase, engineers also focus on blending the flyover into the urban landscape. Noise barriers, landscaping, and drainage channels are added to reduce the environmental impact. Once the ramps are complete, the structure is ready for the final phase: testing and inspection. The engineering marvel above us. Next time you drive over or under a flyover, take a moment to think about the incredible engineering happening above your head. What looks like a simple concrete bridge is actually a symphony of design, geometry, physics, and human effort. It's a perfect example of how humans continue to shape their world, not just on the ground, but above it. So the next time you cruise over a smooth, elevated highway, remember, beneath your tires lies years of engineering research, tons of steel and concrete, and thousands of hours of labor, all working together to keep you safely moving forward. Thanks for watching. And if you love learning how the world is built, don't forget to like, share, and subscribe, because we're just getting started on uncovering the marvels of modern engineering.